because some of you are not here due to sports, I wanted to make a video for this page. It's the back of the handout that you got. And number 5, you're going to draw a pool on your graph paper. So you'll need a new piece of graph paper probably. But for this pool, you're going to choose an X by X. So maybe it's a 4 by 4, maybe it's a 5 by 5. Whatever you want to choose for your X, that's fine. But the area of that is going to be X squared, right? So for your pool, it's going to be X squared as your area. Now for the deck, this deck is on 2 sides. So I'm going to kind of split it up so you can see what we have here. This piece right here is going to be 15 because it's 3 by 5. This piece, though, is going to be 5 by X, and this piece down here is going to be 3 by X. So for our whole deck, it's going to be 3x plus 5x plus 15. So for your deck, you're going to have to figure that out for your numbers, okay? And then our total area, our whole function, is going to be x squared. I'm going to combine these. So that's going to be 8x plus 15. That's the total area. Then you're going to plug in your number for here, whatever your x was, you're going to square it, you're going to multiply it by 8, and you're going to add 15. Again, put your number in here. You are going to just square it. That's for your pool. And then you're going to put your number in here for the deck, and you're going to multiply it by 3. You're going to multiply your number by 5, and you're going to add 15. And then you're going to say what that equals. For part E and F, we are going to come back to that. Actually, what we're going to do is we're going to use Desmos, or the graphing calculator, to be able to graph it. Okay, and then that's going to show us how to find the vertex and the y-intercept. Okay, so our equation that we had on pool number 4, I want to put into y equals. So then I had, it was x squared, so x is this button here, x. Squared is right here, x squared. Then we had plus 8x, so 8. The x again is up here. All these little funny letters, x, t, theta, n. And then plus 15. Now, I don't know if it's going to graph it nicely or not, so I'm just going to hit graph. Cool, it did graph it nicely. If not, you could always go to zoom, and you can do zoom standard, zoom fit. So to get to that, I was up at the top and I just put up. That brought me to the bottom. It's the 0 one, so if I just put 0 on here, it'll choose zoom fit, and there it made it like so. And then I can zoom out if I want to. And I just put zoom out, and sorry if my iPad's all over the place. But I want to know the vertex. The vertex I'm going to find by calculating. So see above the trace it says calculate. So I have to push the blue button and then calculate. Since it's the vertex, I want the minimum. So I'm going to scroll down to 3, push enter. Left bound means I want the left side of the parabola, so I arrow over. Right bound means I want the right side of the vertex, so I just arrow over. And this is my minimum, so that's going to be my guess. So it's basically 4. So now it's giving it to me exactly. -4, -1. All right, so in my notes I want to put vertex and I'm going to put it at -4, -1. Now I want to find the y-intercept. So going back to my graphing calculator. Values, so I'm just going to push enter. When x is 0. So when x is 0, enter, y is 15. And it does not look like that, but when you look at our equation, that would make sense that when x is 0, y would be 15. So I'm going to go back and put that on my worksheet for my y-intercept. All right, so my y-intercept is 15. We should write it as 0, 15. That's more proper. And the roots we can find by factoring. But if you look at our picture up here, this looks like x plus 5 and x plus 3. It's our factoring model. And factors of 15 that add up to 8 are 3 and 5. So it's x plus 3 and x plus 5. What that tells us is that's where our parabola is going to cross the, where it's going to cross the x-axis. So I'm going to show you how this looks in, and then that way you can copy it onto your graph paper. So we have x squared plus 8x plus 15. All right, check it out. We have our vertex. See, this is easier than the graphing calculator, but I still want you to know how to use the graphing calculator. And then these are our factors. Why are they negative? We're going to get into that more when we start topic 8, but because it was x plus 5 and x plus 3, our roots are -5 and -3, and so you can graph this on graph paper, which I will provide. Now you're going to draw on pool number 5, and pool number 5 is a 3x4 pool. So the pool is 3x4 no matter what. That's the swimming pool. So the area of the pool is 3x4, which is 12. Then you're going to draw a deck around the whole pool. And the deck that you draw can have any width. It can have a width of 1, it can have a width of 2, a 3, 4, 5, 10, whatever you want it to be. That's your x. So your pool is automatically 12, but your deck is a little bit tricky to figure out. But we have an x by x in each corner. X by x is x squared, so every corner is 4x squared. Then you have this piece of deck, which is 3x on both sides, because it's a width of 3, and you have this side, which is 4x on both sides. Altogether, 3 plus 4 is 7, and you have that double, so 14, right? 3 plus 4, 3 plus 4, 7 plus 7, that's going to be 14x. If we put the pool and the decking together, then the function would be 4x squared plus 14x plus 12. For this piece up here, to find your deck and your area, you have to figure out what your x is. So if it's 5, then it'd be 5 by 5 times 4, and then you'd have a 3 by 5, 3 by 5, a 4 by 5, and a 4 by 5 to figure out your total area and your decking piece. So whatever number you choose for your deck, you're going to plug into here. And then this will be 12 no matter what. This piece you have to plug in your x for into this equation. And then you have to plug in your x into this equation to figure out your total area and the total area of your deck. Okay. Next, we're going to find the vertex and the y-intercept, as well as the roots by factoring. To find the vertex and the y-intercept, we have to put this equation into a graphing calculator. So 4x squared plus 14x plus 12. Oh, wrong calculator. Desmos. We have 4x squared plus 14x plus 12. And I'm going to zoom in to see our vertex. Our vertex is here at negative 1.75, comma negative 0.25. So our vertex is negative 1.75, comma negative 0.25. Now, to figure out the y-intercept, I'm going to have to zoom out, but I know what the y-intercept is just from my equation, because I can see that if I plug 0 into x, 4 times 0 squared plus 14 times 0 is just 0 plus 12. So when x is 0, y is 12. And you can see that in our graph way up here. That is our y-intercept, 0, 12. The next thing it's asking is for us to find the roots. So to find the roots, I have to factor it. The first thing I'm going to do is factor out a 2. So I get x squared plus, 2x squared, right? Because if I divide by 2, from my original equation, I get 2x squared plus 7x plus 6. Multiplying 2 and 6, I get 12. And factors of 12 that add up to 7 are 3 and 4. So I'm going to write this as grouping. 2 parentheses 2x squared plus 4x plus 3x plus 6. I'm going to group that. So for this piece, a 2x can come out, leaving us with x plus 2. And for this piece, I can pull out a 3, and then I'd be left with x plus 2. So my factors are, I have x plus 2 twice, and then I have 2x and I have 3. So my factors are, first I factored out a 2, then I have 2x plus 3, and I have x plus 2. Those are my factors, and you can see these factors. They're kind of tricky, but the 2x plus 3 is going to give us 1.5 because it ends up being, or negative 1.5, negative 3 over 2, and then my x plus 2 is negative 2. We're going to talk about this later in the chapter, but you can see them right here and right here. Those are our factors. Okay. For pool number 6, you are going to draw a pool of your size that you choose. It's going to be x in width, and it's going to be twice that in length. So for example, if you chose 5 for your width, then 10 would be your length, because you would double it. Or 2 and double it 4. If you chose 3 for your x, then you double it, you would get 6. Okay, so draw that pool, and then draw a decking that is 3 feet wide all the way around. Okay, so your pool area is going to be 2x times x. So 2x times x is equal to 2x squared. Your deck, I have to look at the picture. Your deck has 4 corners. These 4 corners are 3 by 3, so each corner is 9. And you have 4 of them. So 4 times 9 is 36. Your deck is going to be something plus 36. You also have, your deck is 3 wide, so it's going to be 3x on both sides. And then it's 2x in length, times 3. So it's going to be 6x. Together, 3x plus 6x is 9x. 3x plus 6x is 9x. 9x plus 9x is 18x. All right. Together, you have this piece and you have this piece. When you put them together, you have 2x squared plus 18x plus 36. Okay. We want to graph this function into Desmos. Two x squared plus 18x plus 36. Need to zoom out. My vertex is negative 4.5, comma, negative 4.5. Okay, so my vertex is negative 4.5, comma, negative 4.5. My y-intercept, I can see it from my equation. It's going to be 36, because if I put in 0 to x, 2 times 0 squared is 0, 18 times 0 is 0, I'm left with 36. So if I plug in 0, I get 36. We can see that in our graph because the y-intercept is up here at 0, 36. When you graph this, you're going to need a lot of graph paper because it goes all the way up to 36, to infinity. But at least you need to have 36 on your graph. The next thing that they asked us to do was to find the roots by factoring. The roots are this part, here and here, negative 6 and negative 3. So how do we get that? Let's go back to our equation. We can factor out a 2. So 2x squared, factoring out a 2 is x squared. 18 divided by 2 is 9. And 36 divided by 2 is 18. What are factors of 18 that add up to 9? Well, 3 times 6. So we have x plus 3 and x plus 6. And then we have the 2. When we look at the graph, we are going to see a negative 3 and a negative 6. Right here and here. So you'll want to put those on your graph as well when you graph these on graph paper. And that completes the third part of our practice, of our project.